This screencast looks at ionic substances versus covalent substance, and this would be how you could determine experimentally whether something is more likely ionic or covalent. So ionic compound or ionically bonded substances we call compounds, and the representative that we're going to use in these experimentations is sodium chloride or regular old table salt. On the covalent side, covalently bonded substances are called molecules, and we're going to use sugar as our representative compound in these laboratory exercises here. Now, we can look at the formulas. You can see in ionic we have a metal and a nonmetal, which is characteristic of ionically bonded substances. We get those oppositely charged ions involved. In our representative molecule here, we have all nonmetals. So this is not made of ions. They are formed with the sharing of electrons. Okay. First, we're going to look at the melting points of these two substances. I put them on a hot plate and expose them to exactly the same amount of heat. And you can see the sugar begins to melt and does so very quickly, while the salt remains unchanged. So what we can say from that is that ionically bonded substances have higher melting and boiling points, whereas covalently bonded substances have lower melting and boiling points. We could also say ionic compounds tend to be hard, brittle solids at room temperature. You can imagine or think about salt crystals laying down on the table in front of you. They're going to be very hard, but you could cleave them in half with a knife if you needed to. Covalently bonded substances, now while sugar is a solid, most covalently bonded substances are gases or liquids at room temperature. Gases like oxygen gas, nitrogen gas, carbon dioxide gas, all of those are around you right now in the air. Liquids like water, those are very popular covalently bonded substances. Sugar is a solid at room temperature, but that's the reason, or the reason for that is because it is such a huge molecule. And we'll get to the chemistry reasons why size makes a difference in the states of matter a little bit later. Okay, next we're going to look at another difference between ionic and covalent substances. So in this video, I have a conductivity tester. It is plugged into the wall socket, so I'm going to use a stirring rod to show, to point things out so I don't shock myself. So we have two electrodes right here, and they are unconnected. And that the reason the light bulb is not lit up is because the circuit is not complete. Now, if we were to put this into a solution that had some ions in there, the ions, or those charged pieces, could move from one electrode to the other electrode and complete the circuit. When that happens, the light bulb will light up. If we put this in a solution that does not contain ions, there are no charged pieces to complete the circuit. So the light bulb will remain unlit because the circuit is not complete. Now, we're going to be using the same two substances that we were using before, so salt and sugar, and I've mixed them with water. So the first one has sugar dissolved in water, and I used about the same amount of sugar and salt in about the same amount of water. Now I'm going to put the conductivity tester into the sugar water. You will notice, you can see that it's in the solution and the circuit remains incomplete. And that's because there are no charged pieces, no ions. Now if I put it in salt, the light bulb lights up, and that's because the sodium and the chlorine have separated into charged pieces, sodium ions and chloride ions, and those can move from one electrode to the other and complete that circuit, lighting up the light bulb. You can see as I move this in and out of the solution, you'll see that the light bulb goes on and off. Then if we put it back in sugar, no light bulb because there are no charged pieces. Back into the salt, and the light bulb lights up as we put those electrodes into the solution. because again, the ions are moving from one electrode to the other. There has to be ions present for something to conduct electricity, or for a solution to conduct electricity. And we call those solutions electrolyte solutions. So you may have heard that from Gatorade, and it is true, Gatorade does have electrolytes, but those are just ions, and for Gatorade it means that it has salt in it, which you would need to replenish if you were really exerting yourself. But as far as most of us with our normal everyday diet, we do not need to replenish our salt or our electrolyte contents. But ionic compounds do form electrolyte solutions, and that's because those ions split apart, and those charged pieces can conduct electricity. Covalently bonded substances do not form electrolyte solutions because there are no ions to move the charge.